If CEST technology becomes more mature, it may help doctors see which brain regions have abnormal glutamate signals, whether there is metabolic excitation around a seizure focus, whether certain subtypes of psychosis or depression involve specific brain region abnormalities, whether children with autism-like regression have a distinct neurotransmitter metabolic pattern, and whether glutamate signals come down after treatment. But right now, CEST is still affected by many factors: pH, magnetic field homogeneity, water content, and the tissue environment. So it is promising, but for now it remains mainly a research tool. The fifth direction is multinuclear MR and metal-sensitive imaging. The brain contains more than sugar and lactate. It also depends on ion balance, and it can carry traces of metal deposition. Standard 1, HMRS, cannot directly measure copper, iron, manganese, or zinc the way a CSF metal test might. It does not simply give you a copper peak or an iron peak. More often, it shows metabolic traces left behind after metal balance or ion homeostasis has affected brain cells. For example, a decrease in NAA, a change in choline, the appearance of a lactate peak, or an abnormal energy ledger on 31 PMRS. The technologies that come closer to an ion window are mostly multinuclear MR research methods. For example, 23NA MRI can study sodium concentration in brain tissue. It is like asking whether the brain cell's saltwater pump, which maintains the sodium gradient, is losing balance. 39K MRI is also being explored for potassium in the brain, but it is still at an earlier stage. 31 PMRS can also provide indirect information about free magnesium ions and energy metabolism. For metal deposition, the more mature tools in clinical care and research are often not MRS. They are MRI techniques sensitive to magnetic susceptibility and relaxation. For example, iron deposition can be studied with SWT2 star, R2 star, and QSM. This is important in NBIA, neurodegeneration with brain iron accumulation, and in some other neurodegenerative disorders. Manganese overload often affects the basal ganglia. A classic